Welcome to today's episode of the video review of the R&S RTB2000 series oscilloscope, the Siglent SDS2000X Plus oscilloscope series, and the Keysight DSOX1000 series of oscilloscopes. This video is part of a series of videos reviews on these three oscilloscopes, and each of the episodes talks about different sets of features of these devices. So if you're interested to see something about the other features, then please look at the opening episode or any of the other episodes that I've already posted or I'm planning to post. Today we're going to look at the user interface of these devices. That means that we're going to take a look at the screen and the graphical user interface. We're going to look at the way that traces are being displayed. We're going to look at labels, screen annotations, the grid and how it can be customized, and other customizable features of these devices. Before we actually look at the screen interface of the devices, I'll quickly go over the main specification of the instruments. So we see that the R&S RTB has a large 10-inch screen. It has a high resolution, approximately 1 megapixel shows on the devices, and that is divided into 12 horizontal and 10 vertical grids. And the interface is capacitive touch. It allows multi-gestures in a number of different ways and also supports an on-screen keyboard. The Siglent SDS has the same size of screen as the RTB, a 10-inch screen. Its screen resolution is somewhat lower. It's about 60% of the actual number of pixels as we see on the R&S, and that's divided into 10 horizontal and 8 vertical grids. And it also, similar to the R&S has capacitive touch, all types of multi-gestures and on-screen keyboard. The Keysight DSOX actually is rather different in a few ways. It got a much smaller screen. It has a much smaller screen resolution as well. We're only left here with about 1/3 of the RTB resolution and divided into 10 horizontal and 8 vertical grid divisions. Then about the screen interface and how we can customize that for particular use. Both the RTB and the SDS have extensive grid customization. We can do tracking of grids and a number of other things. Also, both of these devices can show the axis values along the shown grid, although a little bit different in the way that they do it, we will see later. All of the devices we're looking at today can show labels for individual traces and also for mask traces and reference traces. They differ a little bit in length, and later we'll see also in the way that they are made and can be shown. The RTB and the DSOX can show screen annotations on the device. The SDS does not support that. Then some of the devices allow you to select a trace color. The Siglent SDS is the most powerful there. It allows you to do both for analog channels and also for other channels. The RTB only allows you to do this for reference and mask channels, and the Keysight not at all. And then finally, the RTB and the SDS also allow dynamic trace colors, like rainbow type of colors that give you information about how often a particular value actually is present when you look over a larger set of waveforms. For today's review, we will be using the web access interfaces that all these three devices offer. Let's go and take a quick look of the R&S here. We got the web interface opening page here, and to go to the remote front panel, we click here and we can actually choose to auto scale it, which basically means that we can make this any size that is convenient for what we're doing on the screen. For Siglent here, this is the opening screen, and we go to instrument control. Here we don't get to see the physical buttons of the device. It's going to be limited to just the screen controls. However, any functionality will be available from here. But it's a fixed size screen, so we have to try to make it as big. It's going to take most of my screen here, so we got everything within view. We need to move the R&S a bit. And then finally here, the Keysight, we can go to control instrument panel, remote control, opening another window. Also, this is a window of a fixed bitmap size. We do get the whole physical surface, so we can use any of these buttons over here. However, there's something specific about this screen access, because it is not installed as a standard on the Keysight oscilloscope. You have to install a separate piece of software to enable this, and you have to do it in the same way that you install a firmware upgrade. It's slightly confusing because you have to go into the procedure of a firmware update, but instead offer another file that actually adds a piece of software. It takes quite a bit of time. In the end it works well, but my understanding is that once you install a new base firmware on the device, you have to re-go into this procedure and also add a new web access piece of software to support this. Now, all my three devices are now online, so we should be able to see the screen of all three of them. Yeah, and that's what we see happening right now. So any action I will be doing on any of these devices should reflect here on the screen, and I can also control them basically all right now from the screen. Where the update rate of the Keysight is pretty low. It takes like a part of a second before we get any update. All the other devices basically are kind of instantaneous in the sense that they update their live screens. About 2 weeks ago, my son came to me with a stepper motor and some control electronics and asked me to help him with trying to get this stepper motor running. What was the optimum speed, what were the best micro-step settings for the controller, etc. So this is a little test circuit that we built together. We got a pulse generator, we got a controller which is actually two H-bridges running the coils of the motor and which can be programmed in a number of different micro-stop settings. And then on the motor itself we made a dish with small openings and a laser diode on the one side and a phototransistor on the other side, so we could somehow count the speed of the rotating motor. Now, how did we measure that with the oscilloscopes? We basically measured it on a number of different points. Here we go a little bit more in detail. So first of all we measure the pulse frequency coming out of the pulse generator. Then we measure the voltage over each of the coils and the current flowing through each of the coils. The voltage is with differential probes because they don't share a common ground setting with this H-bridge. So one of them is a 1 to 10 differential probe, the other is a 1 to 50 differential probe, so we can see how the scopes deal with that. The current is measured through Hall effect devices, and finally the revolutions per minute are measured by this dish, and this dish has exactly 60 openings in it, so that means actually we get 60 pulses per minute. And so this is how the little setup looks in REL, and this little dish here with these 60 openings, that is something that we made ourselves with a 3D printer, and it worked out perfectly fine. Basically to measure the number of turns per minute. Now let's get started and actually experimenting with the three oscilloscopes and look at the signals that we have prepared and get a bit of a feeling of the web interface that we get with it. So we start here with the Roden and Schwarz. The inputs of the scope are all turned off. At least my setup is not powered yet. So quickly, what do we see here? We see all the 4 channels and the digital channels that we've pre-configured. We see the grid here, and the grid is showing us basically the value for the grid. And since I turned track grid tracking on, we would actually see that if I move to a different channel, actually the grid moves with it, and also here basically the settings adapt, as you can see here, to the particular channel that I have selected. Down here for each of the channels we see the probe settings, and we can see here this is a differential probe, which is a 10:1 probe. I've set it to 20 megahertz bandwidth limiting because it's actually low frequencies I'm measuring today, and it's DC coupled. Over here we see a current probe, so we probably see it being configured at 100 millivolts per ampere, also bandwidth limited. Here we got another differential voltage probe, and it's a slightly different probe, and actually this is a 50-to-1 probe as we see here. Fortunately all the devices are able to configure that properly. Here again we got a similar current probe as for the second channel, and here we get at the bottom to see the digital channels, we also get to see the threshold, and we get to see the current values. And my measurement setup is still not powered, but we see that one of the digital inputs is high by default, we see that here, and the other is low by default. So that's the way we get to see our channels. Now I also would like to see some labels so we can understand later exactly what are the signals coming in here, and all of the free oscilloscopes that we're looking at today support trace labels. So now I'm gonna turn them on. We're going to take a look how that works. So the Roden and Schwartz basically allows you to go here to the label menu per channel and edit a label, and I've already prepared labels for the various settings here, and I can turn them on. So we see the label coming here. It's fairly small, but it can be very well read also on the actual device itself, because it got like a full shadow behind it. Now, to turn on the labels for the other channels, I can go to each of the individual channels, like channel 2 and channel 3. But actually, I would like to use this opportunity to show something about the use of the quick access menu. Because suppose you have something you want to turn off regularly, on and off. What we can actually do is that we bring it as a quick online menu. So I just went back to channel 1. I'm taking this label here, and I'm actually making it a quick menu. I'll do the same for channel 2. I'll make the same for channel 3. I'm making the same for channel 4 here. Let me also go to the logic channel. There we go. It also has a label function and also has a label on off. Let's turn away the menu. And so now actually here we have all these quick menus, so I can quickly turn the label for any particular channel on and off. You can do this basically with almost any menu setting, no matter where in the hierarchy of the menu it is. If you got a setting that you want to change often and you don't want to go into that menu all the time, you can do it via this quick access. You can hide them all, you can get them back all. It's a very convenient feature, and if you don't want to see them anymore, you can delete them one by one or delete them all. I will just hide them away right now. Two more things about the labels on the RTB oscilloscope. So if I go to a particular channel, let's go to channel A, and this is now currently the label coil A voltage, right? So I'm going to that channel and I want to edit that label, and then I go to this menu, and when I get to see is D. So actually it doesn't go to the current setting of the label, but it goes to the last label setting that you'll be working with, even if that's on another channel. That's quite inconvenient, I think. Hopefully a software firmware upgrade could fix this, that you actually get to back to the current label. The other thing is that labels are limited to 8 positions. Some of the other devices we're looking at today actually allow much longer labels, but with the RTB you're limited basically to labels of 8 positions here. Now in this particular case I'm looking at a particular setting of the microcontroller in my setup, and one of the things that we could do over here is that we could add a annotation and we could make notes on the screen for future reference. So I could say here TB6600 set to 16 micro steps. I'm entering that, and now we see it on the screen. So if we make a screen print or export in some way, we would have that there. We can move that particular piece of information around to a setting where we would like it. We can actually make also other types of annotations. So if I would see any particular glitch here, I could make a note of that glitch and do something with it. And oh, there we go. And I could use the little wiper here to clean again away the annotation here. Okay, now it's time to turn on our measurement setup and our signals, and I'll do that for all devices at the same time. Yeah, so now we get to see all the channels running. On channel 1 we can clearly see the voltage over coil A, so this is an A bridge, and we can clearly recognize we got 3 different dominant voltage positions here in the H bridge. Channel B is showing us the current flowing through coil number A, and this is at the same time the channel I will be triggering to for a positive edge at the 0 value. And then we get to see the same thing for the other coil of the motor, both the voltage and the current that is flowing through it. I also see the two digital channels. They're not in sync, at least not the last one here, with the signals I'm looking at, but actually I have them here because I want to be able to measure their frequencies and understand the relationship between the pulse control and the final rotation speed of the motor. And I'll turn to that measurement in a little moment. Now let me turn on the measurement statistics, and I prepared a number of statistics already that I'm interested here in looking at. I can turn them on one by one. Unfortunately, there is no global turning on and off of all the measurement positions. You can delete them all at the same time, but then they're also gone. Also something that might be perhaps added one time to an update of the device. So now basically I have added the 6 measurement position that I'm interested in. And so what I'm looking at the peak-to-peak voltages over the coils. That is the first and the third measurement position here, approximately 26 volts, and that's correct. Even though my setup is fed with slightly over 10 volts, it's an H bridge, so it changes polarization, so it can actually get to some higher voltages. We see the currents that go all the way up to about 6 amps peak in my setup, and we get to measure the frequency of the incoming pulse signal to my setup, which is approximately 11 kilohertz, and we get to see the rotations. And since I made a rotation wheel of 60 segments, I'm here seeing the number of rotations per minute. But I could be using the math function and tracking function also to do some calculation on this. So I could divide this by 60 and then I will get the number of rotations per second that my setup is making. Now, finally, I want to look a little bit at trace colors and customizing trace colors. So what we can do here is basically we can select a channel and set it basically to different types of waveform colors. And here I can go to rainbow, and the rainbow color very well reveals to us how often particular values are occurring in a particular scheme. This can be set per individual channel on this in this oscilloscope. I'll also use this opportunity to show another which I find rather convenient functionality. That's the redo and the undo functions over here. So if I go here to the left top and I do undo, then we actually get back and we turn this setting off. Can be done for any setting, so you don't have to go back and find the same menu to turn the setting up. You can do undo, it's even nested, it remembers the last 10 or whatever type of actions that you did. So it's a very convenient way to browse through functionalities. Just as we have a history menu as well, where I can go back to any point where I've been working on before. One thing that we cannot do basically in terms of customizability is that we can change the colors, the basic colors of the waveforms. At least the analog waveforms are fixed. We can change the colors of math and reference. There's some details in the document. We can change colors, I think, of the digital channels. Again, look at the comparison document for all the details. But the analog waveforms on this oscilloscope have fixed colors being assigned to them. Now we are moving to the Siglent SDS2000X Plus oscilloscope, and again we're going to look at its web interface. There are no channels coming into the oscilloscope right now, so we're right now seeing the empty traces here. Now, first a quick look at channel and channel selection. From the web interface we can choose the channels here from clicking on the little thing besides the channel. We can also choose it down here. We get a little visual interface back here because it puts a little bit of a blue line around it. However, if we select channels from the interface over here, we don't see that down there. we don't see right now axis values because that is by default being turned on in the device, but we can activate them. It actually came with a recent firmware update, and we can go to display, we can go to axis level settings, and we can turn them on. So what we see here is that these axes actually move along like with RTB. This is actually because I set it to the so-called moving mode. In the other mode they would be static, but now they're moving along. What we do see is that the axis basically the shown values always get like 4 digits behind the period, also here on the horizontal axis. So the screen gets pretty full because of this. Now here down we see the activated channels being displayed, and we see the similar type of information as we saw before about the settings. So here on the first channel we got a 10 times probe here. We see it's a voltage probe. We're limited to 20 megahertz of bandwidth because we are again dealing with low voltage of low frequency signals. Second channel here we got a current probe. We see it set at 100 millivolts per ampere as well. The third channel, this is actually the 50-to-1 probe, so this little icon here shows it's a custom setting that is made here. The one over here, 4, again is the current probe. 4 is a little bit hard to read, but I must admit this is a trace color that I chose myself. I will later talk about that, and it's not the best color perhaps in terms of readability on this particular screen here. And here we see the digital channel, but no further information which channels are on or about the current state of those channels. Now let us also add some labels here to the various traces so we can understand that what we're looking at. And in order to activate a label, we go to a channel, we go to the label setting, and I've already prepared labels before, but as you can see these labels can be longer here on the oscilloscope, longer than the 8 characters that we had on the R&S RTB2000. And I can turn the display of this particular label on, and I'm going to do that for all the different channels here. There we go. Turning now to the label for the digital channels. These are not turned on and off in the same way as the analog channel. There's one particularity that I would like to get into. You can choose custom labels, and I prepared some labels as well. However, if you go to that menu and let's say we take digital channel now, that's the pulse coming in from my device. If I now enter a label here, like this is a much longer label, it accepts this label, but however, if I go back to the oscilloscope screen, and the labels are kind of hard to read, I think, on this device, we see actually it's truncated. So even if it offers us a longer input window, the actual labels are truncated after all to 8 positions. So let's go back and set back that label here to what it was before, pulse. Something perhaps that could be addressed in a firmware update on this device. Let's go and turn on the signals like we did with the other devices. And here we get to see, of course, we get to see the basically the same type of signals that we saw on the other oscilloscopes. We see that the display is quite a bit more granular than we've seen on the R&S RTB2000 oscilloscope. I think that's because of the 8-bit resolution opposed to the 10-bit of the R&S RTB2000. Even though I did select the 10-bit mode for the Siglent, and actually we see it over here. I find it a little strange it's shown in the time base because it's not really a time-based characteristic, but nevertheless the 10-bit mode is activated. Now this is not a real 10-bit mode. It doesn't have 10 bits of analog to digital converters, but my understanding it is something that is a bit similar to what on other oscilloscope is called the high-res mode, or what I sometimes call like the 16-bit mode, in which there's oversampling used and it might interpolate between values. But these are not real measured values that you are seeing in the 10-bit mode. Also, it's limited to 20 megahertz of bandwidth. What we also see here, I think, is that the labels are sometimes a bit harder to read on the Roden and Schwarz oscilloscope. And one of them is that they're only having partial shadows over it, and so the traces actually go over it. And depending on the type of trace that you have, some of the traces actually, some of the labels actually become almost invisible here. Now, like with the other oscilloscopes, I would like to perform some measurement here. It goes via the measurement menu, and the moment we click menu here, actually we see the measurements already being activated globally all at the same time. I've prepared the same measurements as I did for the other device, so the voltages and the currents and the two frequency measurements, and that all results in the same values, of course, as we have seen before. Now, this device offers quite a lot of measurement positions. Right now we're seeing 4x3 is 1, 2, 3, 4, 3 times 4, 12 measurement positions. And indeed, it depends on the configuration that you choose. You can also go to another measurement mode, which is called M1, which has 5 measurement positions shows in the screen, and M2 basically has more position being shown at the same time. Finally, I also want to talk about trace customization in terms of colors, and on this device that works via the display menu. And let me see, I must pull the menu up to get to the top of it. That doesn't always, yeah, there we go. Oh, I accidentally put it somewhere. Yeah, so we have two things we can do here. We can use color grade, and that is rather similar to what we first saw on other devices as rainbow or fire or other type of coloring schemes. And also here we can very well see how often a particular color value is present in the input signal or not. It's turned globally on and off for all the channels at the same time, not individual per channel. And then finally, and I think I have to go down here a little bit, color settings. And actually what we see here, and this is something that the other devices don't have, is that we can individually select the color per trace, also for the analog channels as we have it here. And we can choose from an actually wide range of colors. This is the blue color that I choose, perhaps a little bit too dark to be well readable here. But we can choose any own color. This is, I think, something particularly useful when you have multiple devices and you would like to have the same color settings on these different devices that you are using. And the screen obviously adapts to the new color, but also the physical LEDs in the buttons of the Siglent device adapt itself properly to the color that has been selected by the user. Now finally we are turning to the Keysight DSOX oscilloscope here, and here we get to see its web interface. What we get to see, we can use the screens here, and we can use the we'll see in a moment the soft buttons that get here, but we can't click anywhere on the screen because it's not a touch interface. We'll see in a moment that I regularly make mistakes there, that I think I can select something. But let's quickly review what we see right now. We're going to see the same channels here in a moment, so I prepared the same settings for the probes basically. So what we see here is our voltage probe 1 to 10. We see our current probe here. It's shown a bit different, but it's actually 100 millivolts per ampere. Actually, let me go to that probe and let me see what value is sitting in. Yeah, here we're nicely seeing 100 millivolts per ampere, but still here it's showing itself as 10 to 1, which is not wrong, but less convenient, I would say. We get to see the 50 to 1 probe. We have to do that via presets on this device, but the 50 to 1 preset fortunately is there, even though we cannot do custom. And the other current probe here. We get to see the same information actually for the channels here, and again we see all of them are bandwidth limited to 20 megahertz right now. Like with the other oscilloscopes, I would like to show some labels here, and these labels could help us to see what the traces are about. So let me go to activate the labels, and that will go via display, via label settings. I can turn on the labels. I already prepared the labels in advance. There's a edit mode, obviously. Here you can choose the channel, and here we see all the channel for which you can choose labels. Now this is where I often make a mistake, because if I'm in the web interface and I'm trying to click here, but I cannot do that because this is not clickable, it's not supposed to be part of the I/O interface of the device. So I have to go to channel here, and I would have to click here on this little entry button to actually go somewhere else. Another slight inconvenience is that even though you can connect, since a recent firmware update, a USB keyboard to the device to change these settings, because if you have to do it via the web interface with a little entry button, that's a horrible process by having to go like letter by letter through that process. But you cannot do it via the web interface. I don't know why. They could have easily done that, but I cannot type it from the computer keyboard. So I have to get a second keyboard and connect it physically to the device here. But having that said, labels are entered here. They are very clearly visible on the screen, even if they take a little bit of space. One thing you might also note here is that no matter where we are, and I'm going back here to the kind of home screen, we'll always have this part of the menu here. It will never be hidden away, so the actual visible part, the tray screen, never gets any bigger than we see right here. I would really have liked to see that you can hide this menu, so you would get to see actually much more of your time base, and this is sometimes disturbing, but there's no way to turn that off. There's always a part of the screen that's going to be masked by the menu setting, even if you're not doing anything in the menu. Now let's start the same signal. We don't have digital signals because this version does not have digital input, so I cannot do that. So I'm going to activate again the same signals. We're going to see the same thing. Also here it's going to be slightly more granular than we see on the RMB oscilloscope. And again, I'm going to post screen prints of what I believe to be the best possible view that I was able to get on these particular devices here. Now, one thing that we can do on this device also is to make annotations. And I think we have to go to the display menu. We can go to annotation. We can activate annotations and we can edit them. As you can see here, I made a quite long annotation. Actually, you can go all the way until 8 lines or something like that. Of an annotation that you're adding here to your screen, and it's going to show up right here. That's a convenient feature, and you can even play around with I think with colors and a number of formatting things. Actually more than you would expect, because otherwise, graphically speaking, this device has significantly less options than the other oscilloscopes, but it's quite strong when it comes to being able to annotate and actually make good documentations of the work that you are doing. Like with the other devices, I would like also to show you some of the measurement statistics, and here I prepared a number of measurement statistics, and they will come up when I choose the measurement button on the device. We'll lose the display here and it will actually go to the measurements. Yeah, we can do the same type of measurements as we saw before. We're getting here the voltages and the currents that are going through both of the motor coils of my step motor here today. Adding measurement and the type of measurement is a bit of a complex process. The idea is that every time you add a new measurement, then the oldest measurement drops off of the list of 4 measurements that you have here. So it's a little bit of a complicated process of being able to do that. But it does work in the end. Finally, turning to waveform customization. Well, the colors of the waveforms are fixed on this device, and it does not offer anything like a rainbow type of function that we saw on the other devices, where we can see the how often particular values occur in our waveform. So that is not an available option on this particular oscilloscope. Okay, this was it for today. Thank you for watching. And I would like to remind you that the document with all the details about the features of these devices and their comparison is available online. I'll attach the link below, and you're welcome to comment on this document, to provide additions or corrections. And when I receive them, I will process them into that document.